Welcome Algebra, and today we're going to have our first video on the statistics unit, and this video is about standard deviation, and it's a word you may have heard maybe while reading an article, maybe while looking up research, something of that nature. Maybe you didn't know what it meant. And a standard deviation is simply a measure of variability. So you have all this data collected, one variable, and we want to know how much does it vary, and that's what a standard deviation is. Our learning target today is that you can find the standard deviation for a set of data and describe what it means. Alright, so we have this dot plot. We learned what a dot plot was last time. It's a number line with dots on it representing where the data lives, and this is for battery life of, I'm guessing, batteries. They tell you the mean. We went over how to find it last time. They're just telling you the mean is 101 hours, and we're going to mark that. So we'll say it's about right here, 101. And your first job is to take a guess at something. So what is the typical distance or deviation? Because deviation really just means how different something is. So what is the typical distance from the mean? And that's for you to decide. I want you to take a guess at how many battery life hours difference there is between a typical dot from this data and the actual average or the mean. So take a second, guess. I'm not going to guess for you, and then move on. Alright, so in a land without calculators, finding the standard deviation is very tedious, and this is actually what you have to do. And it's shorthand here. We're going to try it once together, and then we'll show you how easy it is on the calculator. Number one, it says find the deviations from the mean. So that would be the distance from the average out to every point. And it doesn't matter if it's positive or negative because it's distance, it's not one minus another. Number two, square those deviations. So that's where it doesn't matter if they're positive or negative. They're all going to be positive after step two. Number three, add up the squared deviation, so the sum of all of those squared numbers. Number four, the number of values in the data set is denoted n, so that's how many data points there were. Divide the sum of the squared deviations, what you got in 3, by that number n minus 1. And then you take the square root of this and round to the nearest hundredth. The rounding part is optional. So that's a lot of steps, and you would have to do it every time you had new data. Let's say you added one more dot to the graph, you have to do it all over again. Fun, right? So here's what we're going to do. We knew that the average was, or the mean was 101. The deviation from the mean is just how far that number is from 101. So basically you can do 83 minus 101. You can do that number minus 101 every time. And we'll get negatives, but they won't matter that much. I won't make you do the math either, so I'll just write it out here. I'm looking at my list. Alright, those are just the differences between the average and the actual life of each battery. Then we're going to square each one. Some of these you can do in your head, some of them not as easy. There we go. Now we want to add all of them up. If you add all of them up, you get 736. N, keep in mind, is how many data points there are, and it looks like 1, 2, 3, 4, 5, 6. So n minus 1 is 6 minus 1, which is 5. And we're going to divide those two things, because it said the sum of the squared of the deviation is divided by 5. And you get 147.2. And then we take the square root of that, and we get 12.132. It goes on a little more, 60071. I think that's how far the calculator goes, which is approximately 12.13. That's it. That's the standard deviation. So you would compare your guess that you made in the beginning to this number 12.13. That is a number that represents how far away from the mean a typical point was. And actually, we can be more precise about it. It's something you don't really need to know this year, but it is very helpful to get an idea of what standard deviation really means. And this is called the bell curve, and it's the normal distribution of data. And what you do is, here's the exact average. The mean is right in the middle, and one standard deviation away on either side will represent always 68% of the data. So within one standard deviation either side of the average, there are 68% of the dots. When you go out another standard deviation, what you have is 95% of the data. It's hard to write that in here somewhere. And you go out again, I think it's like 97.8, or it gets within 3 or 4 standard deviations, you basically have all of the data. Alright, here's another little optional thing. So this is brand B batteries, apparently, and they have their own set of data for how long their life was. The deviation is filled in for you. But if you want to practice the rest of this, I would pause it right now, try it, and then in like a second, the answer at the bottom will pop up. Actually, the whole thing will fill out. So if you want to see if you can do it without making a mistake, awesome. So pause it. And here it is. So that's great if you got through the whole thing and never made a mistake. Alright, so why the heck would we need standard deviation? And this question gets to the heart of it. So now we have computed the standard deviation of the data on brand A and brand B. We did brand A together. Brand B was that optional one. But either way, that's the answer. Compare the two and describe what you notice in the context of the problem. So, in other words, we don't want to just talk about numbers. We want to talk about what the battery, in context means talk about the batteries too. So if I'm a company who is testing out a new battery, and I have this data, I'd probably have a lot more data than they gave us here. And my first standard deviation was 12.13, and another one was 19.61. What does that mean? What number am I looking for? Do we want a small standard deviation? Do we want a big standard deviation? Well, standard deviation is a measure of the variability. So if you're a company, do you want a battery whose life varies largely from battery to battery? Do you want your customers to put in a battery and be really excited because it lasted 8 hours, but then the next time it lasted 5, and then the next time it goes back to 10, and then so you wouldn't really want that. So we, as a battery company, would not want a high standard deviation. We want a low standard deviation, which means all of the battery hours are clumped together a little bit better towards the center, closer to the average. So that's what standard deviation measures. It's a nice single number that represents kind of how wild our data is. Alright, and speaking of wild, this is wildly easier than what we were just doing. So in green here it says using the calculator to find the mean and the standard deviation all at the same time. Mean is not so bad. If I asked you to find the average of a number or of a set of numbers, it's pretty standard. But your calculator can even do that part and then do all of that junk that we did to find standard deviation. It does in half a second. So we have this set of data. Looks like it says heights of 8 different men. We're going to enter that into the calculator just like we enter for regressions. Regressions require data, so it doesn't mean, median, mode, all that stuff. Alright, from the home screen you press Stat, where all statistics go, and you go to the editor. We're used to this, but we're only going to make one list. This is single variable statistics, so we only make one list. Alright, we're going to do this together in class, but I do want you to follow along. most of this is a little bit overboard with how detailed we're getting, because you've done a lot of this before. You've done 3. You've done 4. You actually don't need to quit to go to the home screen. You can just hit stat. So this is kind of a pointless step right here. You hit stat, you go to calculate, and instead of picking a regression, those first 2 things are kind of like main. They give you lots of details, and we want the one that says 1 var stats. That means 1 variable stats. That means we're only going to be using 1 list of numbers. You hit enter, make sure that it says L1 or whatever list you used, and press enter again, and it shows you a summary of a bunch of things. And actually it shows you more than we're going to list here, and we'll talk about all the things it shows you in class, but you can see if you can guess at what things it's giving you. Some things we haven't learned about yet. But the 2 things you need to know is that the mean, or the average, is the x with a bar over it. That value is the mean. And then the standard deviation is S of x. I'm not sure. We're going to say S of x, but we say maybe either way. I think the S in this one stands for sample standard deviation. And sample deviation is used when we have a sample of the total population, and we'd use this symbol. You'll see it in your calculator right near it. It stands for sigma x, and that's when if you have the entire population. But we actually will never use that. It's weird. Even when it probably would make sense to use it, it confuses us on the region. So the regents has said just use SX every time. Whatever that number produces on your calculator, look at SX. Here's one you can try yourself just to see if you are doing the calculator stuff correctly. So take a second, try it, and then pause it. Here you go. Hopefully you did it. We're going to do one last thing before we finish up here as I punch the board, make lots of sounds. I'm trying to get rid of these highlighting things, but they don't like going away. There we go. So suppose that every person answers all 4 questions on the questionnaire. And I forget, this goes with the question I kind of skipped. It was just data's number of questions answered on a questionnaire. And there was a few questions about it. But this one says, suppose that every person answers all 4 questions on the questionnaire. So that means there'd be 10 dots, because I think there was 10 people. You'd put a dot here, and you'd make 10 of them. Is that 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. It's a really interesting looking dot plot there. We can calculate the mean and the standard deviation without using our calculators. It says, what is the mean number of questions answered? That is the average number of questions answered. Well, if every single person answered 10, then answered all 4, then that is the average. It's 4. So that's not, it's like if you had 100 in every class on your report card, your average is 100. If you had a 90 in every single class, your average is a 90. But what is the standard deviation? Remember, that's the typical distance away from the average a point is. And since there are no numbers anywhere outside of the actual average, then the standard deviation is 0. So it's just important to know what that means. A 0 standard deviation means there is no variability in the data. The data does not vary at all. That's where we're going to finish it up. We'll talk a lot more about this in class next time. Have fun. Good night.